5 times 5 is?
25.
Yeah. Hey folks, welcome out there this afternoon. It's so good to have you tune in with us. I'm Ernie Roberts. I'm your host for Mathline. And that's where you are, folks. You see the little words down there, Mathline? My goodness, we got Facebook on, we got a number going. The number is 844-686-2378. What you do? Give us a call, all right? And have a math problem for us to work out live together on the air. Hey, help you out, help kids out, help everybody, all right? Usually I'm finding out when we get certain calls. I know there are many, many others who have very similar problems to that, and I'm glad you tune in to see what kind of problems we're going to get today. But you make it happen, all right? Give us a call, 844-686-2378. We are, I know in the midst, some of you are going to school, and some of you are saying, I don't know if I'm going to be going tomorrow because of all this illness and stuff. Hopefully we get better out there, get feeling better. The flu does not take its toll like it did last year, and we want you to stay healthy and stuff. But right now, squirrel around here and let's watch Mathline and let's check out our problem of the day. And this one is about Callie. Callie has borrowed $2,500 from a friend and promises to pay back. Oh yes, way to go, Callie. $2,655 in 6 months. What is the rate of simple interest in this situation? All right, so in other words, we got a little interest, right? We're going to pay back the $2,500 plus, looks like about $155 extra dollars there. But anyway, that's our storyline on this one today. So we're going to try to figure out what kind of rate has this friend charged Callie. And let's see what we've got here. Let's take a look at this. So we have the situation starting with $2,500, a nice round number, I think, from a friend promising to pay back a little extra, and actually that extra interest is going to be $155, which to a lot of you say, well, that doesn't sound like bad. But my friends, that's in 6 months. So this is going to be a pretty decent little rate of interest, but maybe you don't think of this as being a heavy loan. Also notice something about when you pay back interest in 6 months, you're not having to pay nearly as much as you do if you do year after year after year after year. So let's check this thing out and see what we're going to have. I want to go to the simple interest formula. And that formula is I equals the principal, we call it P, times the rate, times the time, and that time is based on an annual year, 1 year, all right? And this is very straightforward. We are not working very hard on this at all, okay? So what we're going to look at is see what happens with the numbers we got. Well, we do know how much interest she's being charged because what we have, we're paying back $2,655 and she only borrowed $2,500, so we're getting $155, as I mentioned, for interest. You say, well, Ernie, what's the point of the problem? You already know the interest. Well, we want to find out the rate. We're going to look for R this time. We're going to look for R. So the principal, I put in $2,500 and hold my breath and see what happens. And then we also go over here and we have, how about it, a rate, which we do not know, a time that we do know. It's 1/2 a year. You say, well, Ernie, why don't you put a 6 in there? Because remember, it says based on annual, and we have 12 months in a year, so 6 months is a 1/2. So we're going to go with 1/2 of that. Picking it up, we can move these numbers around a little bit, so we can go ahead and take 1/2 of that $2,500, which would be nice to do. I'm getting $1,250 out of that. Everybody else at home and on your online moments and stuff, hopefully you're saying yes, yes, yes. And we got $155 right over here. I got to get R by itself. That's all it's missing. That's all it's missing. That's what we're looking for here. So what are we going to do, everybody? What are we going to do? We're going to do, yeah, you got it. We're going to divide. And some of you say, oh, we're going to divide. So some of you are already going like, yeah, 155 into 1250. No, don't do that. No. Let's bring it back up here, all right? We got 155 equaling, once again, what do we have? 1250, basically, times R. We want to divide by 1250. I'll tell you something. If you went the other way, that rate's going to be out of sight. I wouldn't borrow from that friend. That friend's not very nice to do that. Then some of you may have your opinions on this friend too. But let's see. We got the 1250s going away. We have the rate left over. We're going to go to the calculator on this one and see. Hopefully it comes out as something fairly reasonable. We're going to take 155 and we're going to divide it by 1250. And we're going to see where this lovely number takes us. You know it's got to be less than 1. Well, of course it does, because we're going to have to change that decimal to a percent in a minute. Hang on to that. And I'm getting this. The R is 124 thousandths. But remember, when we make percent, we have to move that decimal back 2 places. So this rate is really looking like it's about 12.4%, which is pretty healthy. That's almost getting 1/8 of the money back. Wow, okay? But there you have it, 12.4% rate. Callie, get it paid back. Smart person to pay it back early, because if you got a little further with that and kept that annual rate going, you would have been paying a lot more interest. But being for just a half a year, that makes it move pretty quickly. So there you go. Problem of the day, folks. And Callie, take care of your money and your finances. It's an important thing. And hopefully you keep a friendship after borrowing the money. Now, I understand I have a call waiting for me. And welcome to Mathline this afternoon. Who am I talking with?
This is Dominic.
Dominic, how are you doing this afternoon? Where are you calling from?
Zai.
From where? Whatever. Okay. Give us a call, folks, 844-686-2378. And evidently had a interesting, I don't know what he said, so I'm not going to worry about it. You all give us calls and let's have some good math problems going on the air here. So again, 844-686-2378. That's what we've got going here. Another thing we've got going in Mathline world is problem of the week. And last week we tried to get one in there, but we had some in and outs. We had a day where we were out for snow, a few other things. So this week we're going to try to come back with a full 4-day week thing. And let's take a look at our problem of the week if we can, guys. On the slate here. This one's got a lot of writing. It says the floor plan of a room is drawn to the scale of 1/8 of an inch, equaling 1 foot. And what are the dimensions of a room whose plan measures 1 5/8 inches by 2 3/4 inches? So in other words, we're looking at the plan, a blueprint plan, which is much smaller than the actual size. So a scale there that's important is our 1/8 equaling 1/8 inch equals to a foot. Notice those symbols there. So let's take a look and see how we might get this started. We're not going to work it out completely today, because remember, the whole idea of doing this approach is we get you started and you play with it at home. So folks, go ahead and copy that thing down at home if you're still with me there on that problem. Go ahead and copy it down a little bit there. You've got a scale of 1/8 inch equaling 1 foot. What are the dimensions of the room whose plan is going to measure? It says 1 5/8 inches by 2 3/4. My little hint, for what it's worth, is to think about this 1/8. This 1/8 inch equaling to 1 foot. And I kind of want to think, what does a full inch equal to? And I'm thinking that 1 inch is going to be equal to, it looks like, if 1/8 inch is equal to 1 foot, I think we're going to be able to get 1 inch equaling to 8 feet. That's a nice little relationship that you can work with there. And one other thing I might suggest is, well, as you look at these two little fractions here, how do they relate to that 8? And also, what can you do to make them a little bit more worthy of work, so to speak, helping us out? Now keep in mind, these are inches. We're going to try to translate those to feet. And this is another little thing, another little scaling going there. Not going to tell you much more today, all right? Give you some time to play with that. And while you're playing with that, give us a call, all right? That number, 844-686-2378. Again, we'll post the answers on Facebook and our website at the end of the week, but we'll also work it out on Thursday here in the station on live, so you don't want to miss out on that on Thursday. Okay, finding out the solution and see, are you right? Are you correct? And hey, while you're at it, go ahead and plug it on Facebook and tell us what you think the answers are if you've gotten that far along. All right, so understand we've got a call. I hope we got a full call this time, all right? Welcome to Mathline this afternoon. Who am I talking with?
Marquez.
Marquez, I know I've got a good person with Marquez here. How are you doing today?
Yes, sir.
You're doing good. And from Knox County, right? Am I right?
Yes, sir.
I remember pretty well there. All right. What kind of problem have you got for me today, buddy?
I have x minus 7 equals 4.
X minus 7 equaling to 4. Okay? So this is one of those situations where we're looking at the problem and we're thinking what number, we're looking for a number that's bigger than 7 and 4 probably here. You think that sounds, does that make sense?
Right.
Because you're going to be taking away the 7 and from it and ending up with 4. So the idea is it should be bigger than both of these if you look at them individually. And they're actually going to have a nice relationship for us in just a second. What I'm going to do, and I don't know which, I don't know, what grade are you in? I know we've talked a little bit, and I think you've told me.
6th grade.
All right. And I'm going to go with a couple of things because I know some teachers in the beginning, and it's fine. It's the way we do teach this thing at the very beginning. When you're first learning how to do some equations, we ask you to rewrite the problem, and we look at how are we going to remove this minus 7. All right? I like to say it's hooked in by subtraction. And how do we unhook? We go the opposite, which means we're going to add 7. Do you see how I'm doing that, Marquez?
Yeah.
And I'm going to put that, that's my change. That's a change I did to the left-hand side. On the right-hand side, I am going to be doing the same thing because there's some pesky little property called the addition property of equality. It says I have to add those together. All right? So what happens, though, the beauty of this is the negative 7 plus 7 cancels, which basically gives me a 0. So I'm going to be left with x, which is nice. And over here, I've got this 4 plus 7. I have to just go ahead and not multiply, but add those out. And 4 plus 7 is going to give me 11. And that looks like where we are. Okay? Now, quick check. Quick check. Does 11 minus 7 equal to 4? Because remember what we did, we found a number to put right in here. See what we did? We just went back and checked by substitution. And I believe that does. 4 equals to 4, doesn't it?
Yes, sir.
So, and that's always what you want to do when you start with these little algebra things. What these are, Marquez, is just nice little formal ways of setting up operations, so to speak. And it helps you organize and what have you there. And then always remember, to undo the situation, you've got to basically do the opposite operation. If it's subtraction, we did the addition like we did here. If it had been a plus 7, we would have subtracted the 7, okay, from both sides. Does that make sense?
Yes.
And we always look for a way to make things disappear, all right, and make things look simpler. And I think there's your final answer, and there's your check right there, okay? All right, hey, thanks for calling in today. And folks, you do the same thing, 844-686-2378. We're here to work math problems with you. They can be complex, they can be light, they can be whatever you want them to be. We'll work them and solve them out live here together on the air. Like I said, we have the problem of the week that we ran through. We also had the little simple interest problem we did a little bit earlier with Callie. We just did Marquez's with some good old basic equation solving. And we want to hear from you guys. Send us some information. Send us some things that you would like to see us work out for you. I have one here that I know this is going toward our geometry students. So let's take a look at this problem here while we're waiting for another call to come through. I heard the phones ringing out there, so we'll see if we get another good person to call in for us here. This one says, find the distance between the points -4, 6 and 5, -6. And I'm going to go with two options here, two nice options here. If you've got graph paper in front of you, I think using it is just as easy, if not easier, than using, quote, the distance formula. But a lot of times we have the distance formula there and we want to use it. So let's look at it first from the distance formula standpoint, then we'll put it on a graph, a grid, and do some block counting, all right, and see how that works. And also, I mean, it's basically the same problem. It's just one's a physical representation, one is more of an algebraic work through, solve, arithmetic, all sorts of good stuff. So let's do the good old algebraic, solve, arithmetic, whatever. We got a big formula that says square root, big square root, and D stands for distance, all right? D equals the big square root of x1 minus x2. Now, those aren't squareds, they aren't powers. Those are just first x, second x. Don't get excited, all right? We call them sub 1 and sub 2 for short. We're going to take and square that quantity once we figure it out. The next thing we're going to do, we're going to add on the other side down here to y1 minus y2, which is a squared moment also. Whew, how about that? And there you have the formula. Pretty straightforward. And I may come back and allude to that here in just a second when we work through it again, but let's put some numbers in there. You said, well, Ernie, how do we know what's x1 and x2? Well, how about it? First x, why not? Right there it is. First y, right there it is. Go again. Second x, second y. How about that? That was easy, wasn't it? Just put numbers in. Now watch your signs when we put them in for the substitution. Let's work through. Big square root radical is not going anywhere till the very end. By the way, let's go back over here just a second. What does this formula tell us we're going to do? First, we're going to substitute. I think I need to put the steps out here. All right, we're going to substitute. That's what our first step's going to be. Then we're going to subtract because they're inside the parentheses. We're going to do the subtractions because the parentheses say go there. Then, remember, please excuse my dear Aunt Sally, or whatever you want to call her there. P per parentheses, well, we just work out the parentheses. That's the subtracting part. E, excuse, is for exponents. So here we go. We're going to square. Why? Because there's a second power there, all right? So in working through that thing, we're working on it, okay? We're getting there. Now, what happens from there? You got an addition sign. Don't do that until you get everything squared, then add them up. So we do addition, and then finally, last but not least, we take and do the square root, all right? And so there's our 5-step process. You say, we're going to have 5 steps? Well, we've got the formula written down. Let's put the substitute and see what happens. We're going to put our x's in there. We got a -4. We're going to subtract 5, and we're going to run a little square sign on it. How's that? We are also going to go one more step. We're going to do the same thing with the y's here. They got a 6, and we're going to subtract a -6 squared. And that was easy, wasn't it? So we did the substitute. Check that off the list. Got it done. Now, let's play the squaring part. No, let's subtract first. How about it? I think we need to subtract first. Everybody agrees? Yes. So here we go. We're going to get a -9, which is going to get squared. And over here, oh, and how did I get a -9? Because I said -4 plus -5, right? Gives us -9 there. And let's go check changing signs there. Yep. And by the way, be sure you put that minus a -6. Be sure there's both there. That's going to give us 12 squared. How about it? We are up to square time. I thought we'd be excited about that. By the way, -9 times -9 is not -81. If you tap that in your calculator, shame on you, don't do that. But if you did, be sure to put a parenthesis around it, okay? Because otherwise you're going to get -81 and you'll put the wrong thing down here. Don't do that. And then we got 144. And now we're ready to do something. No, what have we done? We've subtracted, we've squared. Now it's time to add. Don't square root yet. Some of you said, ooh, I see perfect squares. You go right back to where you were, right? So don't do that. Let's add. That's going to give us 225. Now you're ready to take a square root. And it so happens we have a nice, pretty perfect square there. And that is going to give you, you want to check it out? Let's go for a calculator real quick. And then I understand I have a call waiting for me, which is exciting. We will take care of you guys in just a second. Let's get this one finished up. It's 15. It's 15. There you go. Hopefully you guys know that. But for those of you who didn't, that's what we did. We just simply took a square root of 225, which gives us 15. And my friends, we have finished the problem all the way down through there. So a little 5 short steps. You got to follow the formula. It tells you what to do. Now, I said, promise you we would look at that on a graph. We will, but I'm going to have a caller first. So let's take the phone call first, and we'll come back to the graph later here if we have time. Welcome to Mathline this afternoon. Who am I talking with?
Marquez again.
Hey, Marquez again. How are you doing today? Still doing good, I hope, right?
Yes.
Got called back again. Once again, this young man's from Knox County. We're glad to have him back with us. So what's your second problem for me today?
I have 12 equals x plus 8.
12 equaling to x plus 8. That sound good?
Yes.
You know what's interesting about this one is your x is on the right-hand side, isn't it?
Yeah.
They switched it over on you. Now, I'm going to tell you a little bit. We're going to work it out from this standpoint. I said last time we were going to try, looked like I was going to do 2 ways. I want to do 2 ways on this one, but we're going to go ahead and work it out in this manner because it's okay to have the x end up on the right-hand side. I personally like looking at the left, but we're going to keep it there on the right, okay? Marquez, what's keeping you from having that x all by its lonesome there? What's keeping you from having it by itself?
Plus 8.
The plus 8, exactly. And remember when you last called in here, I said something about if there had been a plus something, what would we need to do to remove it? We're going to need to subtract it. Exactly. Very good. So what I'm going to do is I'm going to write that x plus 8 once again, and I'm going to put minus 8 right there. Okay? And I'm going to underline that because that's our change, okay? And that's going to be important just because we want to get a 0. That's why we do that, by the way. So it'll disappear and we have, there's x by itself. But remember what I said earlier? You've got to do it the same thing to what? The left-hand side?
To the other side.
Yeah. So in this case, and be sure you do it in this order. It needs to be 12 minus 8. 12 minus 8. So in other words, there's your change there. There's your change here. We know that's going to go to 0, right?
Uh-huh.
So that's going to give us x by itself. Over here we got 12 minus 8, which you've been doing for a long time, sir. And you get 4, I believe. Does that sounds right?
Yes, 4, right.
So let's check it out and see. The little check moment here. Going back to the original equation. And I put the 4 in for x. And we check it out. And I believe we get it that, right? 4 plus 8, we know is 12. That checks through very nicely. And even when it seems that simple, it's just good to kind of go back and do a check, if not do it mentally, okay? Now, I said I was going to tell you another way we could do this. And it's legal. Everybody's going, ooh, is he going to do something legal? Of course, I always do legal things. We take the x plus 8, we'll move it over here and shift the 12 to the right, okay?
Yes.
I can do that. Because basically, I'm just saying if 12 equals this, this is still going to equal 12, right?
Uh-huh.
Now, for those who've gone through geometry and some higher level algebra, math classes, that we call a symmetric property. That's the symmetry, and we can move the left side of the equation, the right-hand side, and shift them without changing anything. That's the key thing. We don't want to be changing anything as we do that total shift, okay? Now, Marquez, what are we going to do? We're going to do the same game plan we had just a minute ago. We're going to subtract that 8 from both sides. You see where it's going?
Uh-huh.
And those still get a 0, don't we, right there? 8 minus 8 is still 0. You've got an x by itself. Over here we've got 12 minus 8, which you've been doing a long time, and that's going to also give you the 4. And, of course, it'll check back through. So you see how that works both ways?
Yeah.
And I tell my students, don't be afraid of an x popping up on the right-hand side. It's just basically it's working the same way. It's just a little bit awkward to our view a lot of times when we first start doing equations. We like that x to end up on the left. And you know, and it can be done, but you've just got to be careful when you switch things around. You're not switching the order. And I'll go one more step further. If I had, let's say I'd said x minus 8 equals, let's say, 10, okay?
Uh-huh.
And that would be the same way I would write that would be, I'm off the page here, would be 10 equals x minus 8. In other words, notice, see, I still have to have x minus 8 in that order. Okay, I can't decide, oh, I'm going to make that 8 minus x. Won't work, okay? So, in other words, these are the same expressions. What I was going to try to do over there, but I was off the screen. Well, it wasn't going to be one. But you get the idea. That's one thing you just want to watch out for. Be careful when you do that switch on left to right, okay? Hey, thank you, buddy, for giving us a call again. And good to have you with us there, all right? And, one more.
Can I tell you the way that I do it?
Sure. What's the way you do it? Go for it.
Okay, I would write 12 equals x plus 8.
Uh-huh.
Okay.
Gotcha. Uh-huh.
And then I would put minus 8 on both sides.
Okay. So did you put it like minus 8 down below?
Yeah.
And you can do that. Sometimes, like I said, I know a lot of teachers like to teach it with the out horizontally, but yes, definitely. I would do that too. In fact, that's what I do most of the time on Mathline. You know having it, don't you?
Yeah.
Okay, I just wanted to make sure I didn't know where you were in that point. Yeah, so you got x equals what then? 4?
4.
I like that better. I really do. So I'm glad you're being allowed to do that. That's good to see. That's good to hear. All right? And it would work the same way if you have on the other. And I think that's a lot easier than trying to rewrite the problem and put all that minus 8 business, to be honest.
Yeah.
I like to go straight to that. So good for you, and thanks for calling in twice on it, okay?
Okay.
Thank you, Marquez. And yes, folks, different places, different points where you get along the way in your math work. I know when we first start equations, we like to stretch them out horizontally like that, but then after a certain point, you begin to work it in a vertical fashion, and good for Marquez there. Good for all of us. Thank you for calling back there. And again, thank you all for tuning in this afternoon. We always have a great time here on Mathline. One more chance. You've got a few more calls left. 844-686-2378. That's the number. If you don't have a call for us today, save that number in your speed dial and let us do it tomorrow. Speaking of which, I mentioned Facebook. Do we have a Facebook moment here that we can do, guys? Yeah, we do. There it is. Like us, love us, share us, all of the above at www.facebook.com. That's /Mathline online. Want you to have us you in there with us. We want to keep up with you from that standpoint. And you can keep up with us on our problems of the day. And we mentioned YouTube. We've got it going. We have it always going, my friends. We have that one going too, where you can go and subscribe to us at www.youtube.com /just Mathline on that. Not Mathline online, just Mathline. And you can catch our problems of the day. You can catch our Friday shows, our holiday shows, all sorts of good things just for tapping in there. Thank you for tapping in today and watching us. And you know what? We will be back again tomorrow live on time, and we will see you then.